So looking at some extra problems that are on the thing that's called the review for summative number 1, it is not all-encompassing. Remember, you got to do your homework, and that's how you're going to review. Yes, Miss Piper? What? Okay, 11 and 12. So 11, if this will ever load, you start by typing that decimal. So it's the DMS stuff, degrees, minutes, seconds. You type in that decimal exactly how it looks. Oh, but first, I think you have to do the DMS. I always forget to do this on my apps. Do you guys remember where you find that DMS converter? I think it's under apps, like second apps, which is the angle menu, and it's like choice 4 or something. So do you have to type DMS and then the angle? Oh, you type this and then it brings up the DMS thing after that? Okay. So it'll pop out the answer once you do that. Everyone should probably practice typing that, get a little muscle memory. And that's how you're going to end up with second apps, which is the angle menu. And it should give you exactly the answer you're going to write down with degrees, minutes, and seconds. Make sure you use the proper labels. This one, instead of typing in the degrees, minutes, and seconds symbols, because I find them very irritating to find, I just type this in my calculator, where it's really like a converting problem. 3 minutes, if you divide minutes by 60, you're converting it to a portion of a degree. Similarly, for seconds, if you divide it by 3600, you're converting it to a portion of a degree. So if you just type this in your calculator, it'll give you the 79.0625 degrees. It won't say degrees, you got to put the degree symbol down, but that's, in my opinion, the easiest way to get that question right. You can use degrees, minutes, and seconds symbols from your calculator, but do you remember the seconds are hidden somewhere? They're not in the angle menu for some reason. Alpha plus. Because why did they not put it in the menu? I don't know. I don't know. I'm very confused.
That's what they did, is they already had made the button and then realized that they didn't have enough spots for the other buttons. So they just put the other two.
Like, we need a filler for this button. 29 is our next request. Excellent choice. Wait, where's 29? There we are. Okay, so 29 is where they're going to ask you for reference angles. And I believe on the key it says 45 degrees is the answer. What's kind of wrong with me saying the reference angle to that measure is 45 degrees? Yeah, it's radians. And these questions will be multiple choice on the test. So what I would like from you guys is show me a little bit of work so I can see where you were at. And if you get it wrong, then I can make a more informed decision. Because technically, if you get it wrong with no work shown, that knocks you down to a 3. I don't want to do that. Hopefully you don't get it wrong. Now, if you do convert it to degrees, which I think is kind of brilliant, you got to make sure your answer that you're going to give is converted back to radians. So like for most people, they do this, converting it to degrees. It would come out to, I can't calculate that, 675 degrees. Now, that's more than a rotation. So the next thing I'm going to do is I'm going to find a coterminal to 675 by subtracting 360. And that brings you to 315 degrees. So this angle, where it lands, is the same place as 315 degrees, which would be like boom, right here. So remember what the question is. They want the reference angle. So the reference angle is the measure of the distance from the terminal side to the closest x-axis. So I know this is a 45 degree angle. These are always positive, but the answer should have been pi over 4 radians. Okay.
They're always positive.
Reference angles are always positive. It doesn't matter how you got to that terminal side. You're measuring the distance from that terminal side to the nearest x-axis. So think of it like an absolute value problem if you want to think of it that way. Okay. Yes, ma'am. 13. Back up. Oh, good question. So this question, they flat out say here's the radius, but my teacher bolded something. That can't be good. And then it gives you this clue about RPMs, which is a clue about angular velocity. So you're going to start there, and you're going to say that your angular velocity, right now it's measuring at 1750 revolutions or rotations per minute. But we know angular velocity has to be measuring in radians per time. So I'm going to need to convert this to angular velocity by saying 1 revolution is how many radians? 2 pi radians. So whether you, okay, I know on the answer key it says 3500 pi radians per minute. And that's totally fine, but here with my experience, this is what I will tell you. I'd prefer you guys to write a decimal down right here. Even if you're not like doing that on your calculator, like maybe you're carrying the pi with you, the kids who leave everything in terms of pi, half the time they leave pi off of their actual answer when they write it down. So like they'll write down 3,500 and then no pi on it. And then they carry that through their work, and then all of a sudden they have the super wrong answer. So I would prefer you guys just to crank 35 pi in your calculator and give me the 10,000 whatever it is, you know. But that's up to you. All right, so our next step is to find the linear velocity. And remember, you do have a formula sheet, but you're only going to get the front side of your formula sheet with the unit circle on it for this test. So it'll have the unit circle. It does have a linear velocity calculation, a few of them, but the one you're going to use on this question is radius times angular velocity. However, we're going to have a problem. Labels. That's when my teacher bolded stuff. This radius was given to you in inches. We're measuring in radians per minute, and I want my answer in feet per minute. Okay, so good news. I didn't have to convert time, so you can leave it per minute. Bad news, you can't measure your radius in inches. So, y'all okay with me saying this is a foot? Okay, 4 inches divided by 12 inches would be a third of a foot. And then you're going to multiply it by that angular velocity y'all just got in radians per minute. And now I would like you to crank everything on the calculator if you haven't already done so. So those of you who had that like 10,000 number, if you carried that through and you already truncated it, you might be like a tenth or two off of whatever the answer key says. The answer key says 3665.2. And then this is measuring in, remember this is now feet per minute. It will be like that on the test where there's something you have to convert, whether it be time or distance of the radius. So just watch out for your conversions, okay? Make sure you label your answer as well. That's very important. What else you got? You got about 4 minutes. So. Yes, Ms. Piper. 22. Excellent question. So here on 22, you are using your unit circle. This is the number 22 you wanted, right? Okay. And they want the cosecant at negative pi over 4. So depending on how comfortable you are with traveling around the unit circle, if you know negative pi over 4 is secretly here, then it won't be too bad. So they want cosecant at negative pi over 4. Well, the cosecant is the reciprocal of the sine. And the sine at negative pi over 4 is negative square root of 2 over 2. So for most kids, what they do is they just flipsies this one around, which totally is going to work, but we're going to have a little bit of work associated with this. I'm going to show you a shortcut in a minute, okay? This is the cosecant, but no math teacher on the planet would be happy with that answer, right? They want you to rationalize it and then simplify it. So negative 2 square root of 2 over 2, and then the 2's come through and cancel, so you're going to get negative square root of 2. Okay, I'm going to show you the shortcut here though, guys. The negative square root of 2 over 2, that's the rationalized version of the fraction. Like if you think about all of our right triangle trig stuff, it secretly was a negative 1 over square root of 2. Originally, that's what the ratio is. So if you know that's the original, the reciprocal of it would be a lot quicker to find if you just go back to what it really, really looked like. Okay? So just food for thought. Those can get really tricky, guys. Like, for instance, number 25 looks really, like, unassuming. Cosecant is 0. Well, 0 radians, the ordered pair is 1, 0, right? And we know cosecant is the reciprocal of sine. So if you took the sine at 0 and you plugged in a 0 for that, because the sine of 0 is 0, what happens when you take a 0 and flipsies it like this? It's undefined. Now, you do get a calculator on tomorrow's test. So if you really, really were in a jam, you could start typing things and be like, does my answer make sense? Like, for instance, you got to be in radian mode, but here, how do you type cosecant? Let's start there, because there's no cosecant button. You do 1 over sine. So if you were in radian mode and typed 1 over sine of negative pi over 4, it's going to give you an atrocious decimal. But if you're like, I'm pretty sure the answer is negative square root of 2, if you typed in negative square root of 2, that should be the same atrocious decimal, right? Is this an efficient use of your time, though? No, this would just be like, I got 5 minutes left. I'm not sure if I did this one right. Let's double check. Here, if you typed 1 over sine 0 in radian mode, you should get an error on your calculator because it's undefined. That's the undefined and zeros are really mess with kids. So just think about that. If you take the reciprocal of a 0, you're going to get an undefined fraction ratio. All right. What else? I can give you like one more question probably. Yes, ma'am. Number 2 on front. Is that the angle of depression question? Thank you for asking that, because I cannot tell you how many kids got that one wrong because they put their angle in the wrong spot. All right, we got a little damsel. Why's it got to be a damsel? Why can't the guy be in distress? I don't like this question. Oh, okay. Okay, angle of depression is actually out here, guys. So it's a 50-degree angle of up high in the sky looking down. So it's actually down here, right? Angle of depression, angle of elevation are the same measurement. They're located, one's out of the triangle, one's in the triangle. So the only fear I have for you is that a lot of kids put 50 degrees right here, which is whoopsies, big mistake. Don't do that. 15 feet from the base of the tower. Oh, nice and proportional, Abruzzo. Nice job. How long does the ladder have to be? So this, guys, this is the ladder. So we're going to set up cosine. Now this, your mode should be degree. So in degree mode, cosine of 50 equals adjacent over hypotenuse. And if you think about cross multiplying this on your calculator, eventually you're going to end up taking 15 and dividing it by the cosine of 50 degrees. So drawing the picture right, setting up the right trig ratio, and then executing it properly on your calculator. I want to see all of that on your paper because you guys know what happens. You type something goofy, and I can't give you partial credit and a better score if I have no idea where you were at in your brain. It's time. Bye.